So, by now what we have studied is the ARP protocol, the address resolution protocol that maps the address, the IP address to the physical address, and the counterpart of ARP is the RARP that maps the physical address to the logical address. So, this is how the that is how the address resolution protocols work, but when the address is resolved or the a sender maps the physical address to the logical address or the vice versa, how they work, what are the component of these protocols, the ARP or the RARP protocol that helps them to resolve the addressing problem and to find the destination hardware address or the logical address and send the packet. So, to know this we must study the designing of ARP, the ARP design. Likewise, we studied the design of IP. ARP2 has its own designing with its some of the very specific modules, and so to understand that, let us have the diagram of the ARP first and we will study about the modules of the ARP then. So, to have the block diagram of ARP, one of the very important module of ARP is the output module. Along with the output module, it has few more modules or the components you can say. One is a cache table. The job of this table is like any other caching operation, but what are the specification or why this cache table is important, that we will study. Along with this cache table, we have another table which consists of a set of queues with it. So, there are set of queues in this table. So, we say this is a queue table. Then followed by this, there is another important module which is an input module, and these modules are connected like this. The cache table is connected to the queue table directly, and this output module and the input modules are also connected directly. Then to control the contents of the cache table or entries of the cache table, there is another very important module which maintains the cache table, is called the cache control module, cache control module, and this is connected to the cache table. Then few more connections are required, like we will see them later on. So, this is what is the block diagram of an ARP having 5 modules: the input module, the output module, the cache table, the queuing table, and the cache control module. So, with these 5 modules or 5 components of ARP, how it works. Let us have the first table that will describe is the most important one is the cache table. What is the role of the cache table now? Let us say sender A sends n number of packets to receiver B. So, if this is the sender and this is the receiver, now when the first packet is generated, P1 is generated, you definitely need the ARP to be processed, right. So, what happens? Your ARP request is sent to the receiver through any means, you know the different ways, we are not going to discuss that again, and the ARP reply comes back. So, when the ARP reply comes back, now A has the address of, the physical address of B with it. Initially for P1 it generated the IP, it asked for the MAC, it generated the IP and it sent the ARP request to get back the reply, and for B the MAC is found. Now, let us say the P1 will be sent. Is it wise that A should send again the ARP request to ask for the hardware address? Not necessary, right. So, what happens? So, when the ARP reply comes to A, what A does, it maintains the table, or definitely the value of B or the hardware address of B is cast into a table, so that any number of packets generated by the same source to the same destination can follow the same address that was received by the first ARP reply and sent to the receiver. That is the first requirement of having a cache table. So, when this result comes, an entry is made in the cache table for a particular destination along with all the different status. And the resolved address is the known hardware address of the corresponding IP address that was sent in the ARP request. So, now the sender has got the address of the receiver with it. Anytime it can use the address for sending n number of packets. Now, you know the role of any cache table or any cache memory, anything. Can we store this address for an unlimited period in the cache table? Not necessarily. That means we need to update the value of cache table, the entries of cache table for some time, and the same has to be followed by all the nodes connected to the network. Now, what are the entries of this cache table and how they are important for updating the cache table? One of the entry of the cache table is status. The status says, when we say about the status, we say about the entries only, any of the entry in the cache. So, the status can have 3 values, one is a free, another is pending, and another is resolved. So, when the entry in the cache table, for any status, it says it is free means the entry is free, the space is free. So, any new entry can be built and stored in the cache table as per the requirement. So, that is what says the free status. Any entry in the cache table is free. Coming to the pending part, when it says the status is pending for any entry, meaning the ARP request has already been sent and the reply is yet to come from the the receiver. So, the status is pending. Request has already been sent and the reply is awaited. That is what says the pending status for any entry in the cache table. And when the status is resolved, it says that already the sender, or for a particular sender or for a particular IP address, the corresponding hardware address or MAC address has already been received and this is stored in the the cache table. So, 3 status saying a free space, a new entry can be created, saying a pending case, the hardware address is yet to be resolved and to come to the cache table updated, and another is already resolved. So, any packet who needs the hardware address can take this resolved address and send the packet to the receiver. This is what is the 3 status of your one of the entry in the cache table, that is the status. Other than this status, there are few more entries in this, and those are almost similar to the ARP packet frame format that we studied in the last class. The hardware type we have studied in the last class, saying what kind of network it is. Then the protocol type, saying what kind of IP is being used, what version of IP is being used. They are already there in the frame format. And then another is your hardware length also. This was also there. So, these values are copied just to have it the status in the cache table entry. Then the protocol length. These are the same values, those are copied from the ARP packet to the cache entries to have the matching. And along with that, there is an address called the hardware address. If you remember the target address and the target hardware address, target protocol address, right. So, there is a target hardware address, there is a hardware address and there is a protocol address, and these two are same as your target hardware address and target protocol address. These are same as the target values in the ARP packet that we studied in the last class. Now, along with this, there are few more entries in the cache table. One is the TTL. You know the purpose of a TTL. It is the time to live. Any entry in the cache table, when it comes with a resolved state, has to be updated with its aging or time, so that it has to be reduced or decremented by 1 till it becomes 0. Once it is 0, automatically this is converted to a free state and the entry is made free. the space is made free. So, whenever it comes to a resolve state, the TTL is set to some value and reduced every time periodically or by any some event that we will see. So, till it becomes 0 and the space is made empty. This is the value or this is the lifetime of an entry in a resolved case. Another field is attempt. This corresponds to the status of pending. The reason is, when the status is pending, it indicates that a request has been sent, right. It may happen that the receiver is not able to reply back, or the reply has been damaged, or for some any reason, or the request has not yet been sent on the way, it has been lost something. That means for any request, it should have a multiple number of times the request has to be sent. So, and that multiple number should be less than a threshold value. So, how many attempts has been done to send a request, that is updated in the attempt file. If for the same sender and the receiver, let us say for this IP, for any sender IP, first time the request goes, the number of attempt remains 1. If it does not get back any reply within a stipulated time, again the another next attempt is, or the next request is sent, making the number of attempts plus 1. So, this goes on increasing till a threshold value. If it does not get, that means either the receiver is not present in the network, or there is a problem in the network, or somehow there is a problem, and that space is again made free. If it goes to more than a threshold value, number of attempts goes to more than a threshold value. That is what the field. So, TTL, then attempt, and there is another is timeout. This timeout is required before sending the next request. So, anytime if a pending state goes for pending for a certain time period, timeout occurs, then automatically the next attempt takes place, or the next request goes by increasing the attempt by one more value. That is what is a timeout value. Along with that, there is another entry called the queue number. This queue number corresponds to the value, or the, if you see there are multiple queues in the table, so it corresponds to a particular queue. Why, how that comes through, we will see that. So, this is what is the, for any entry in the cache table, a corresponding queue number will be added, meaning the particular queue is for a single destination, and the request or any entry, any status that is maintained in the cache table corresponds to the particular queue. So, a single queue maps to a single destination. That is what is the queue number entered into the cache table. So, now your cache table having the status field, the hardware address field, the protocol address field, the hardware length, the protocol length, then the TTL, then the attempt, then the queue number and timeout. With all these values, if one entry you fetch from the cache table, you get all the details about the network or the ARP protocol. That is what is your cache table. Then the next module in the ARP design, as we studied, is the output module. Coming to the output module, because this is a ARP protocol and we studied that ARP protocol is a sister protocol of your IP. So, definitely this is working in which layer? In the network layer. So, your IP packet or the data that comes from the upper layer is built into a datagram and comes to the, becomes an IP packet. I said this is an IP packet, or you can say even the datagram, the same thing. It comes to the output module first. When it comes to the output module, what is the option? It will first see, because this IP packet contains what? This contains the IP address, right? If you remember DIP, the destination IP address. So, what it does? It first checks the cache table corresponding to this DIP, that is destination IP address, if there is an entry in the cache table or not. If there is an entry in the cache table with a status of resolved case, when it comes to the resolved case, meaning what? Already the protocol has received the hardware address of the corresponding destination. So, simply that value is copied into the protocol and it goes to the next layer. It goes to the next layer. This is the IP packet with the resolved address, with resolved case. That means the hardware address of the destination is known. So, simply it can go to the, where it will go? It goes to the DLL, the next layer. Let us say the status is not a resolved case. So, either it could be a free state or it could be in the pending state. If the state is pending, if we say the state of the output module is pending, if it is a resolved case, so it goes to the, directly goes to the DLL. When it becomes an pending case, meaning what? When it says the status is pending, meaning the sender has already sent an ARP request, and if the ARP request has already been sent, definitely a queue has been built for that, because as I told you, each queue maps to a corresponding destination. So, now it checks for the queue number in the field whose value is pending, and in that queue number it enters the packet. The packet is now enqueued into the corresponding queue for the same destination for which it is looking for the packet, because you know that for every destination there will be multiple packets. So, now it is enqueued in the corresponding queue matching with the queue number in the cache table, and the packet is now enqueued into this. If the status is pending, if the status is free, what happens then? What is the meaning if the status is free? That means this is the first packet for the destination. So, an IP request has to be sent and a corresponding queue has to be built, right. So, if this is the free case, if this as we discussed, if this is the pending case, it enqueues the packet into the corresponding queue. If this is a free case, meaning a queue has to be built, first thing. Second is an ARP has to be sent, and when the first ARP is sent, what happens here? The attempt has to be made, attempt is set to 1, right. So, what happens when the hardware module finds that there is no entry in the cache table? So, what it does? It creates an entry in the cache table. First of all, it creates an entry in the cache table, then it makes builds a queue, enters the packet into a queue, and the corresponding queue number is now entered into the cache table. That means now this queue belongs to the destination, setting the attempt field equal to 1 and sending the ARP request to the next layer. So, what it does is it sends an ARP request. Is that clear? So, output module, when receives the packet from the upper layer, checks for the 3 status of the in the cache table. If it is resolved, nothing to do, simply takes the value from the table and sends to the lower layer, that is the DLL. If the value is pending, status is pending, that means it is understood that the queue has already been created by the same destination. So, it enqueues the packet into that, and that is all. Then if the status is free, it creates a new entry in the cache table. The packet will be entered into a queue, and that queue number is mapped with the status queue, the cache table status queue number, and an ARP request will be sent. That is what is done by the output module. So, these all activities has to be done when you develop the algorithm for each of the module. What are things done by every module, right. So, now this is output module is done. Next, coming to the input module. Okay. So, before that we will have a little bit study on the queue. As we discussed, queue has got several queues in it, and each queue corresponds to the value of any destination, and for a particular destination whatever packets comes into the queue are enqueued into the same queue. Okay. Now, coming to the input module of the ARP. What the input module does? The job of the input module is it dequeues the components or every packet from the queue first. It tries to dequeue the packet from the queues, these are all the IP packets, if it finds the status as the resolved case. If the status is found to be resolved from a particular queue, then the packets comes here to the input module and then it goes to the next layer or the DLL. So, IP packet with the resolved hardware address. The very simple job of your input module. Now, let us say the input module, someone else, the whole of the IP or whole of the ARP is a receiver, let us say. That means either it can receive a ARP request and it has to send the ARP reply, right. Coming to the hardware address, if what we studied is coming to the input module, if I say this ARP is working for a host who is a receiver, that means an ARP request comes to this, right. This is an request and this host has to send the reply saying that I am the host and my hardware address is such and such. And this part is done by the input module. So, when it receives an ARP request, it first checks for the cache table, seeing that if the state is free, that means for the first time I am getting the request, right. So, what it does, when it gets the request, it first checks if the status is resolved, right. That means I have a hardware address mapped for this and this hardware address is sent to as a reply to the node who has sent the request in a ARP reply packet. Another case is, let us say the status is pending for the entry. That means it is yet to receive the hardware address, and again what it does, it sends the number of attempts to 1, increases by 1 and sends the packet, wait till this status becomes resolved. Then once it becomes resolved, it again sends back the reply. And another is, what are the different fields we studied? The TTL, yes, once it becomes the resolved state, the TTL is, once it becomes resolved, the TTL is set to a value, right. And this cache table is, as we discussed, is updated by the cache control module who takes care of the cache table. So, what it does, it scans the cache table entry by entry, checking what is the status field. If the status is free, nothing to do, it goes to the next entry. If the next entry is a resolved case, then it decreases the TTL by 1 and checks if the TTL is 0, then it simply frees that entry, makes the space or makes the entry free because it has already expired its age. If the status is pending again, it increases the number of attempts to +1 and sends an ARP request again. And this will be sent only when this attempt +1 is less than threshold. After incrementing to 1, if it finds that it is still less than the threshold value, it sends an ARP request. If not, again this space is made to free. So, it is the cache control module who maintains the cache table and makes the space free for the new entry inside it by seeing the different conditions, the TTL or by the number of attempts. So, this makes the free space. The output module checks for, creates a new space if there is no entry, and the input module dequeues the value from this and sends to the corresponding receiver. That is how the 5 modules work together and your ARP is done. So, you have your IP packet with the resolved hardware address, then you have a ARP with ARP packet, maybe it may be a request or it may be a reply. And then another is when the IP packet is, ARP packet is a reply, it goes out. So, when either request comes in, the reply goes out, or if the reply comes in, then accordingly the value is set in the cache table by making the entry resolved, then making the TTL set and the rest of the things, and then the queuing of the or dequeuing of the packet from the corresponding queue is then starts with sending to the resolve address. Input module, output module with the help of your cache control table, cache table and the queues. That is how your ARP works along with the IP packet or the datagram that you study. Now, can you link all this, the IP datagram, the different fields of the header field in the IP datagram, the hardware address, the destination address, the source IP address, the destination IP address, when it goes an ARP request, how those addresses are mapped or linked, and how those values or hardware addresses are changed, and even they are linked with the queuing table, I mean the cache table, and how a corresponding queue is built, and that is how the whole of the ARP works or supports the IP to build a datagram and route the packet and delivers it. That is why we say network layer is responsible for end-to-end delivery. One host, if source is the host and the destination is the end-to-end delivery is the responsibility of the network layer. It finds all the way from the source, finding the different options of the different routing tables, different paths, delivering the packet to intermediate hops, then again finally delivering to the last hop or the host whose hardware address maps with the IP address of the source, I mean the original datagram. Searching, then forwarding, searching and forwarding, mapping the intermediate values and sending to the corresponding receiver. That is what is the job of your IP layer with the help of your internet protocol or the IP and the ARP, and same is true also for the RARP. The only difference is the address maps in a reverse way, that is all. And another sister protocol for IP is, as I discussed, Icmp, Internet Control Message Protocol. You know, you sometimes get an Icmp error. Has anybody experienced that Icmp error message? Or IGMP, Internet Group Messaging Protocol. So, those are the protocols when in any of the system or the route of the packet from the source to destination, if there any of the node fails or the routing could not be done, then you get an Icmp message or an IGMP message. Those two are also some of the sister protocols. We may study that. We will try to cover those also. Along with, they work along with IP and they do the job.